All right. Good afternoon. We'll get into the homework exercises in just a moment, and but just for right now, just wanted to mention a little something about intercepts, and we have here. Okay, just kind of get things started off, and there's really not, at least I don't think in the book there's really no smooth introduction to determining both kinds of intercepts. So I just thought I would just begin with the mini lesson, and just for determining x and y intercepts, and we have, okay, just for the labeling. Okay, so we have for x intercepts, okay, now the general coordinates you want to have at x0, and this is going to be, by definition, okay, location, the location where the graph is going to cross or touch the x-axis. Okay, so if you notice with the coordinates, now you're going to have, say, in an equation that consists of the variables x and y. What's going to happen here is that for each x-intercept, you're going to be looking at setting y equal to 0 and solve for x. And we have, in the case of the y-intercept, okay, there's a little bit of an inversion of the language. Okay, now for the y-intercept, now the general coordinates you're going to have at 0, y. And now for each y-intercept, okay, this is going to be the location where the graph crosses or touches the y-axis. Okay, so in comparison to what we have with the x-intercept, okay, so you're just switching around what you're solving for and what you're setting to 0. So if you notice, we have with the coordinates, and keeping in mind that all ordered pairs are of the form xy. So you're going to have setting x to 0 and solving for y. And this will apply for all equations in the xy coordinate system, regardless of whether the equations are linear or not. And let me give you just kind of a intro here. So if you're looking at determining the x and the y intercepts, and we'll say first case here, we'll just have as a linear equation, whereupon we have 2x plus 4y is equal to 12. Okay, so in the determination of the intercepts, so we have for each x-intercept, again, we have the general coordinates to be x0. And for the y-intercept, again, the general coordinates we have at 0, y. And so we have, again, so for each x-intercept, you're setting y to 0 and solving for x. 2 times x plus 4 times 0 kind of doing a little bit of color coordinating just to get back to the statement up here. And we have is equal to 12. And 4 times 0 is 0. So we have 2x is equal to 12. And we have with division by 2, okay, we're going to come out to x is equal to 6. Now for the y-intercept, same equation, and this time we are now solving for y and having x set to 0. So 2 times 0 is 0, and we got 4y is equal to 12, and we have for the outcome, we had that y is equal to 3. Okay, so we have x at 6 for the x-intercept, and y is at 3 for the y-intercept. And so we're going to have, just taking what we have here, so we have x at 6. And if I were to express in coordinate fashion, we're going to have the x-intercept at 6, 0. And as for what we have in the case of the y-intercept, now we have y to be determined at 3. So you have the y-intercept located at 0, 3. And just looking at what we have as a bit of a visual. Okay, so again you have your y-axis and x-axis. Okay, and we have with the y-intercept and the x-intercept respectively at 0, 3 and 6, 0. And of course for the line that represents 2x plus 4y is equal to 12, it's going to be a straight line, and it's going to go through these 2 points among infinitely many others. Okay. And again, so we have infinite points, but out of those infinite points there are only 2 intercepts, one on the y-axis at 0, 3 and the other on the x-axis at 6, 0. And for what we have, let's say if we have so we have a nonlinear equation. And so we have x squared plus y squared is equal to 16. And say if I'm looking for the x and the y intercepts once again. So again, I'm looking at for each x-intercept, solving for x as y is set to 0. And once again, I have the reverse scenario and looking at solving for the y-intercept. So in the setup for the x-intercept part, okay, so I have x squared is equal to 16. And again, so we have, if I look at the use of the square root property of equality. Now you could set this up as a quadratic, like x squared minus 16 is equal to 0, factor, and then utilize, okay, the zero product property. But if you keep x squared and 16 apart and just utilize the square root property of equality, we're going to have x at plus and minus 4. And the same thing is going to happen for the setup in y squared. We can either set y squared minus 16 equal to 0 and factor to get the values of y, or again, we can utilize the square root property again. And so we're going to have that y is equal to plus and minus 4. So we have for the x and the y intercepts, so we have for x, plus or minus 4. So you have the x-intercepts. If I draw these out separately, so you have 4, 0, and negative 4, 0. And for the y-intercepts, so you have plus or minus 4, but this time you have the positive and negative 4 as the second coordinate. So 0, 4, and 0, negative 4. Okay, and so for the figure in this one, okay, so that's going to be a circle, okay, with a radius of 4. You got 0, 4, 4, 0. 0, negative 4, as well as negative 4, 0. Okay. And again, now what we had before with 2x plus 4y is equal to 12, that is a function since it satisfies the vertical line test. And again, circles are not functions since you have, for many of the x values, you have 2 corresponding y values. But still, regardless of whether we have a function or a non-function, if we have x and y terms, there is the potential for there to exist x and y intercepts, okay, as is the case with the linear function and also with the circle. All right, so I wanted to give kind of a brief intro to this because there's really nothing in the book that provides a smooth introduction for both x and y intercepts, it seems, but you're going to be looking at both of them as we get further out into the subsequent chapters involving functions. All right, now in the case kind of going back to what we have in working with, let's see, that was number 6 in the case of page 176. So we have okay, so we have for these items, okay, we're making kind of a segue to parallel and perpendicular lines, and we have in number 6, okay, so you're looking at the slope-intercept equation of a line that's going to have the following features, one of which is going to be where we have the line is going to pass through the ordered pair for negative 6, and also where the line is going to have a slope equal to 3. And so for what we're going to have here, okay, so in getting to the slope-intercept equation, can we be looking at going through the point-slope pathway. Okay, so we have our given point and slope already provided. So for y minus, y of 1, so we have y minus negative 6. And we have equal to the slope m, which we have at 3. And we have times the quantity of x minus 4. And so we have y plus 6 is equal to 3 times, okay, the quantity of x minus 4. Okay, now I could have gone ahead and distributed, but I just did want to mention that in this format, okay, now this is the point slope equation. Now, in looking at the slope-intercept equation, so I'm going to distribute 3 over the quantity of x minus 4. So I have y plus 6 equal to 3x minus 12. And now getting the y term by itself, if I take 6 away from both sides, we're going to have y is equal to 3x minus 18. And so that is going to be the slope-intercept equation. And you can always go back and check. Okay, so for this outcome, okay, so you got the slope at 3, and to see if 4, negative 6 belongs on the graph of this equation, so you got y at negative 6, and with x at 4, 3 times 4 is 12, 12 minus 18 is negative 6, both sides equal each other, so the slope-intercept equation here does check out for the slope of 3, and 4, negative 6 as being among the points through which the graph is going to pass. Now, in the case of what we have with number 12, now we're still looking for the slope-intercept equation, and instead of having the slope provided with just one point, we have 2 points through which the line is going to be passing through, labeled out. Okay, so we have the 2 points through which the line passes. Okay, we're going to have it negative 4, 8, and also negative 7, negative 3. Okay, so we don't have the slope given. But we can, on the basis of what we have provided with the ordered pairs, okay, we have enough information to be able to get to the slope. And again, in the process, okay, you can go ahead and identify what your first and second x and y values will be. So let the first set refer to negative 4, 8. So negative 4, we have x of 1, 8 is y of 1. For negative 7, negative 3, say negative 7 is x of 2, and minus 3 is going to be y of 2. Again, we have with the slope formula, we have y of 2 minus y of 1 all over x of 2 minus x of 1. Okay, now we have the values stored up. And so we have y of 2, we have at negative 3. We got subtracting now y of 1 we have at 8. X of 2 we have at negative 7. We have minus x of 1, so we have subtracting negative 4. Alright, so you got minus 11. We got negative 7 plus 4. And for the slope, now we're going to have a non-integer value. So we got negative 11 over negative 3. Here the negatives are going to cancel out. So the slope is equal to 11/3. Now, in the case of what we have with the point slope equation set up, now you can choose negative 4, 8. Or negative 7, negative 3. For x1, y1 in the point slope equation. Okay. Again, you can choose either of these, and I tell you what, just again, either set will work. So we'll go with negative 7, negative 3 on this one. So y minus y of 1 is equal to the slope m times the quantity of x minus x of 1. So you have your x of 1, y of 1 from negative 7, negative 3. Again, we have the slope value is at 11/3. So if I fill in, so you got y minus y01, so you have y minus -3. And we have the slope m at 11/3. Then we have times the quantity of x minus -7. So we now have y plus 3 is equal to 11/3 times the quantity of x plus 7. Okay. And let me just mention, okay, so this part, okay, this is going to be the point slope equation upon choosing -7, -3. Now, if I had chosen -4, 8, I would have a different point slope equation, but it will still lead to the same slope intercept equation. And looking at distributing what we have on the right, okay, so we have y plus 3 is equal to 11/3 of x. And we have 11/3 times 7, so this is going to be 77/3. And we have, upon taking 3 away from both sides, so we still have 11/3 of x. And now for 77/3 minus 3, I'm just kind of work to the side here, so have 77/3 minus 3. So I have 77/3 minus 3 over 1. We have 77/3 minus 9/3. So for that difference, okay, we have 68/3. So we're going to have for the slope-intercept equation, we have 11/3 of x plus 68/3. Okay, and okay, so this is going to be the slope-intercept equation. Now we'll mention, okay, now you can test the consistency. So again, so I got fractions, but say if I test out the first point, say if x is -4, you have 11 times -4 is minus 44, so we've got minus 44/3 plus 68/3. -44 plus 68 is going to be 24. 24/3 is going to be at 8. And we have with -7, -3. Okay, let me mention, okay, have -7 times 11, have -77/3 plus 68/3. So you have -9/3, and that goes to -3. So this equation is going to check out. All right, let's see what we got here. We have with number 23. Now you have a given slope. Whereupon we have the m is equal to 3/11. Okay, now if I'm looking for the slope of a line that's going to run parallel, and you have for the slope of the given line at 3/11. Now for a parallel line is going to have the same slope and guess what? So if the given line has a slope of 3/11, a line that runs parallel to the given line is going to have the slope at 3/11. Now, for a perpendicular line, okay, this is going to have an opposite sign reciprocal slope. Okay, so what this is going to mean here, okay, so you have opposite sign reciprocal slope, so that means you have the slope of the given line is at 3/11, and if I take the opposite sign reciprocal of that value, that is going to be the slope of the perpendicular. So I'm going from a positive to a negative. and the reciprocal of 3/11 comes out to 11/3. So the slope of the perpendicular is going to be minus 11/3. And let me mention, okay, now we have with perpendicular lines, the product of their slope values should come out to -1. So you have like m of 1 times m of 2. You have 3/11. And again, for the perpendicular, we have the slope at -11/3. And you have 3 positive times the negative is a negative. And you got -33 over 33. And so this will come out to -1. And again, just again, the product of the slopes, perpendicular lines, okay, will be -1. Right. And for 26, okay, now we have the slope of the given line to be -10. And we have for a parallel line, again, you have the same slope. So given line has a slope of -10. Well, guess what? Parallel line also is going to have a slope of -10. And for the perpendicular, line, again, you will have the opposite sign reciprocal of -10. Okay, so you're going from a negative to a positive, and reciprocal of 10 is like reciprocal of 10 over 1, so this will come out to 1/10. And again, we have with the product of slopes, so you have m of 1 times m of 2, you have -10 times 1/10. So you have -10/10. Okay, so we have at -1. And now, I don't think I had mentioned this exercise, but just in testing whether the lines are going to be parallel, perpendicular, or neither. And you have, in the case of 32, okay, so you have so you have 2x plus 3y equal to 7. We have 4x equal to -6y plus 2. So, and you're asked, okay, if they are parallel, perpendicular, or neither. Okay, so we have, so to determine if they are parallel, perpendicular, or neither, we need to know what the slope values will be and how the slopes relate. If you have the same slope, lines are parallel. If you have opposite sign reciprocal relations, that is, if the slope values multiply to -1, then the lines will be perpendicular to each other. Okay, so we have, first of all, for 2x plus 3y is equal to 7. If I look at determining, we're going to have for the slope, so I'm going to take what I have here and put in slope-intercept form. So we have an isolating the y term. We now have that 3y is equal to -2x plus 7. And we have with division by 3. Okay, so we have that y is equal to -2/3 of x plus 7/3. Okay, and so from the slope-intercept form, okay, so you have with y isolated, okay, the coefficient or number that is alongside x, that is going to be the slope. So you have the slope equal to -2/3. Now, for 4x, equal to negative 6y plus 2. Okay, so you have the y term on the right hand side of the equation, and I'm just going to go ahead and isolate this. So I'm going to take 2 away from both sides. So you have 4x minus 2 is equal to negative 6y. Then we have in dividing by negative 6. Okay, so you have with the first term, so you have 4x over negative 6, and that is reducible to negative 2/3 of x. And you have negative 2 over negative 6, so this will be a plus 1/3. Negative 6y over negative 6, so this will go to y, and so just reversing. Okay, kind of like going from b is equal to a once again to a is equal to b format. We have y is equal to negative 2/3 of x plus 1/3. And so we're going to have that the slope is equal to negative 2/3. And guess what? So for what we're going to have in consequence, we had the slope here at negative 2/3. Slope here also at negative 2/3. And since we had the same slope, it's going to turn out that the lines are going to run parallel to each other. Okay, so if you had the lines to be distinct, that is different. Okay, because here we have, upon translating, say y is equal to negative 2/3 of x plus 7/3. We have y is equal to negative 2/3 of x plus 1/3. So you have different y intercepts. And okay, so if you had, if there were, okay, now in terms of what neither would translate to would be, okay, first of all, if you have different slopes and the difference is not such that you would not have an opposite sign reciprocal either. And the other neither situation would be is if you happen to have the same y-intercept, negative 2/3 x plus 7/3, or negative 2/3 x plus 7/3. But for what we have here, we have distinct lines, same slope, and the lines are going to be parallel. Right. Now, for what we have, say, in devising, okay, equations for lines, and for 37, we'll make this into kind of a two-part question. Now for 37, now it was asking for the line that is going to run parallel. The one I'm going to do here, I believe it was just asking for the parallel. And we have N37, say you're looking at determining the equation. Of the line. That's going to run through to 5, and is, and we'll say first of all, okay, you're going to have to run parallel. To the line defined by the equation 2x plus y is equal to 6. Okay, so you're going to have, okay, so you had the point through which the line runs is going to be at 2, 5. Now, you have the given line represented by 2x plus y is equal to 6. Now, again, to look at the relation. Okay, we need to be able to establish the slope. So for the given line, we have it 2x plus y is equal to 6. And if we get the y term by itself, so as to translate this equation along the lines of the slope-intercept form, okay, so you have upon taking 2x away from both sides, now we have the slope-intercept equation is going to be at y is equal to negative 2x plus 6. And so we're going to have from this, okay, so you have the slope-intercept form, and what is next to x is going to be the slope. Again, for the parallel line, okay, so again, parallel lines, you're going to have the same slope. Okay, so the first line has a slope of negative 2. Parallel line, okay, have a slope of negative 2. And the point through which the parallel line passes, again, is 2, 5. Now looking at setting up what we have along the lines of the point slope algorithm, we have y minus y1 becomes y minus 5. We have equal to the slope m, which we have at negative 2, times the quantity of x minus x01. So this is going to translate out to negative 2 times the quantity of x minus 2. And we have with distributing. Okay, so negative 2 times the quantity of x minus 2. This is going to be negative 2x plus 4. And getting the y term by itself, okay, so we have upon adding 5, we'll come out to y is equal to negative 2x plus 9. Again, so you have in the slope-intercept, you still have the slope at negative 2, and checking for the consistency regarding the order pair 2, 5. So y is at 5, and I want the right-hand side of the equation to also be at 5. So we have negative 2 times 2 is negative 4. Negative 4 plus 9 is 5. 5 is equal to 5. Okay. Now, if I'm looking at the equation of the line that's going to run perpendicular, so running perpendicular to 2x plus y equals 6. Now I'm just going to take what I had earlier, just copy this, and we have in the case of the perpendicular line, okay, so yeah, perpendicular line, and again, perpendicular lines are going to have, we use OSR, like opposite side reciprocal slope values. Okay, so for the given line, okay, the slope was at negative 2. Now for the perpendicular, I'm going to take the opposite side reciprocal of negative 2, so I'm going to go from a negative to a positive, and flipping the 2, so this is going to be 1/2. And again, the point through which the line passes. Okay, so you have going through 2, 5. Again, just sort of stressing once again, so you have the product of the slopes. Perpendicular lines will be at -1. So you got -2 times 1/2. Product of the slopes, again, we're going to have at -1. Now, we have, in the case of the point slope equation setup, okay, so you have y minus 5. Now we have is equal to 1/2 times the quantity of x minus 2. Now we have y minus 5. Okay, and we have with distributing. So we have 1/2 of x. And 1/2 of -2 becomes -1. And adding 5 to both sides. So we're going to have that y is equal to 1/2 of x plus 4. So just looking at what we have here, so y is at 5, with x at 2. 1/2 of 2 is 1, 1 plus 4 is 5, 5 is equal to 5. Okay. So that checks out. Now, for number 39, I'm going to sort of set this up as a two-part scenario again. And for this one, okay, so we have determined the slope. To determine the slope-intercept equation of a line, okay, that's going to run through so we got in this one. So you have 6, -4. And it's going to run perpendicular. I think 39 had asked just for the perpendicular part. But I'm going to throw in both scenarios, and one reason is that, or one potential reason is that if you look into Alex, you know, it'll start out asking for the parallel first and then the perpendicular next, but there might be an immediate follow-up question or problem where it's going to ask for the perpendicular first and then the parallel after. Okay, so you have running perpendicular to x minus 5y is equal to 1. Okay. So for what we're going to have here, okay, we have with the given line. And just like 2x plus y is equal to 6, we don't have the slope-intercept equation provided. Okay, and so if we work and convert to the slope-intercept form so as to arrive at the attainment of the slope. Okay, so we have upon taking x away from both sides, So we have negative 5y is equal to negative x plus 1. And we have with division by negative 5. And so we're going to have that y is equal to, now negatives will cancel out here. So we have y is equal to 1/5 of x minus 1/5. And from this, okay, so the slope is equal to 1/5 and for what we have for the perpendicular line, again, the slope values will have opposite sign reciprocal relations. Okay, so we had the slope of the given line, we have it 1/5, and for the perpendicular, okay, so that slope is going to be at minus 1/5. Again, the product of the slopes are like 1/5 times negative 5. Again, we have at negative 1. Again, we have the point through which the line passes. Okay, so we have at 6, negative 4. And we have with the point slope equation set up. So we have with y minus y of 1, so we're going to have y minus negative 4. We have equal to the slope m, which we have at negative 5, times the quantity of x minus 6. So we have y minus negative 4. So we have the change over to y plus 4. And so we have with distributing negative 5 over the quantity of x minus 6, we have negative 5x plus 30. And in the case of isolating, what we have for y. So we're going to have that y is equal to negative 5x plus 26. And again, so that is going to be the equation of the perpendicular line. Okay, and if I check for consistency, so we have y at negative 4, and I want negative 5x plus 26 to also equal negative 4. So with x at 6, negative 5 times 6 is going to be negative 30. Negative 30 plus 26 is also negative 4. And if I'm looking at that which is going to run parallel, just throwing in this part here. And what I do here, okay, so I got the same given line. Now for the parallel, okay, again, parallel lines will have the same slope. So this time we have m is equal to 1/5. And we've got the same point. So we have 6 and -4. And we have with the point slope equation set up. So we have for y minus y of 1. Okay, so we have y minus -4. We have equal to the slope m, so we have at 1/5. We have times the quantity of x minus 6. So we have y plus 4 once again. And looking at going from the point slope equation to the slope intercept. So if I distribute the coefficient 1/5 over the quantity of x minus 6, so this is going to be 1/5 of x minus 6/5. And we have upon taking 4 away from both sides. So y is equal to 1/5 of x. Now for -6/5 minus 4, I'm just going to mention they're like -6/5 minus 4 over 1. And 4 over 1 is going to become 20 over 5. So we have -6/5 minus 20/5. So this would be a -26/5. So we have for the slope-intercept equation, we'll have 1/5 of x minus 26/5. And you can just check for the consistency. So the left-hand side of the equation, y, we have at -4. And then with x at 6, we have 1/5 of 6 is 6/5. 6/5 minus 26/5 is going to be a -20/5, and -20/5 reduces to -4 again, which we have for y. And tell you what, just for the next few moments, okay, for looking at the slope intercept, so we're looking for the slope-intercept equation of a line. That is going to run through 410. And we'll say that for the first case, okay, we say that it is going to be parallel to the line that is going to be represented by the equation 2x minus y is equal to 7. And then we have for the other part, still working with the same given line, and we'll be looking at that which is going to run perpendicular to 2x minus y is equal to 7. So again, we're working with the same given line. And okay, now for the parallel and the perpendicular lines we have going through 410. And let's see what slope-intercept equations we get for those. Okay, tell you what, if we look into what would be the parallel and the perpendicular lines, we have with that which represents what is given. Okay, so we have 2x minus y is equal to 7. Now just take over here. For the given line. Okay, so I have 2x minus y is equal to 7. And if I look at isolating the y term, so as to be able to express the equation in slope-intercept form. Okay, so taking 2x away from both sides, I have negative y is equal to negative 2x plus 7. And if I just multiply the equation by negative 1, or just change the signs, in other words, make what was negative positive and vice versa. So we have the slope-intercept, okay, we're going to have at y is equal to 2x minus 7. Okay, so we have for the slope, okay, so the slope value is going to be equal to 2. And for the equation of the parallel line, again, parallel lines are going to have the same slope. So the slope is equal to 2, and the point through which the parallel line passes, we're going to have a 410. Alright, so we have with the point slope setup, so you have y minus y1 is equal to m times the quantity of x minus x01. So you got y minus 10 is equal to the slope m, again, so I have it 2. We have times the quantity of x minus 4. And we have upon distributing, okay, so you have y minus 10 is equal to 2x minus 8. And getting the y by itself. So in adding 10 to both sides, so we're going to have that y is equal to 2x plus 2. And so for what we have here, so just testing out, say the slope is at 2. For 410, y is at 10. And I want 2x plus 2 to also be at 10. So with x at 4, 2 times 4 is 8 plus 2 is 10. So the objective is met for this part. And in the case of the perpendicular line, okay, so again, the value of the slopes, or the values of the slopes, will be opposite sign reciprocals. So for the perpendicular, okay, we have the opposite sign reciprocal of 2, which is going to be negative 1/2. And we still had the same point through which that line is going to pass. Okay, so we have y minus 10. And if we get too far ahead, so that's going to be y minus y01. So we're going to have y minus 10. Okay, so we have is equal to m, which we have at negative 1/2. Then we have times the quantity of x minus 4. So we have y minus 10, and we have with distributing, we have negative 1/2 of x, and negative 1/2 of negative 4 becomes positive 2. and adding 10 to both sides. So we now have that y is equal to negative 1/2 of x plus 12. Okay, so we have here, so y is at 10, and I want negative 1/2 of x plus 12 to also be at 10, so with x at 4, negative 1/2 times 4 is negative 2, and negative 2 plus 12 is also at 10. Now, there's an item that would be in reference to kind of working with slope in the context of average rate of change of a function. But I think what I'll do instead, and this will be a little bit of an advance, but I think it's going to be kind of a smoother transition. And now when we first looked into functions, especially crossing over into the vertical line test, okay, now some of the items that were functions, they ran continuously, something like y is equal to 3x plus 7. But you'll have those that can have broken off sections. We have like intersection at one point for some portions between the vertical line and the graph, and also you might have had a split where there was no point of intersection. And those items could be like samples of what are referred to as piecewise defined functions. Okay, like for piecewise defined functions, okay, you have like a real life example could be something like tax brackets for federal returns. So like in the case of a Form 1040. And this would be like on the monetary side of things. Well, let's say that just kind of in the case of functional notation, I would say just as this particular case. Let's say if you have given a piecewise defined function whereupon we have f of x is equal to 2x plus 5. It'll be equal to that part on the condition, or if we had that x is less than negative 2. Now, if the input is a different quantity, say if the input should be such that we have between negative 2 and 5, and we'll have that y is equal to 3x squared. See, if we have that negative 2 is less than or equal to x, which in turn is going to be less than 5, and we'll say that we have for the remaining tier, okay, we can say that y is equal to f of x is equal to 3x plus 4 if it so turns out that x is greater than or equal to 5. And say we have given this and we were to determine so you have f of 20, f of negative 40, f of 4, and say we have rounding out, say we have f of negative 2, and also f of 5. Okay, now in the case of f of 20, so you have like on a graph, okay, so your x value is at 20, and your y value that corresponds is going to be f of 20. And it's like, okay, which of these sections am I going to use? Well, we have, in the case of the input, the x value of 20. Now 20 cannot be less than itself. 20 does not fall between -2 and 5. But now for what we have in the case of x is greater than or equal to 5, so with x at 20, 20 is greater than or equal to 5, and this is going to ring true for the greater than portion. So that means 20 belongs in this last category. And in terms of what to do with 20, you're going to take 3 times that and follow through with the addition of 4. So 3 times 20 is 60. And we have 60 plus 4 is equal to 64. And in the case of -40, say for f of -40, well, -40, that is already going to be less than -2. So for those inputs that are less than -2, we're going to apply the 2x plus 5 treatment. So here we have 2 times -40 plus 5. 2 times -40 is -80 plus 5. So whenever x is -40, we have the y value that corresponds to end up at -75. And for what we have in the case of f of 4, okay, now 4 is going to fall between -2 and 5. Okay, so again, for the first half of the compound inequality, the less than portion is going to comply. -2 is less than 4, which in turn is less than 5. And so we're going to apply the 3x squared treatment. And 4 squared is 16. And we have 3 times 16 is going to be 48. And we have now, if you notice, we have the inputs -2 and 5, and those appear twice among the inequality cases laid out in the piecewise defined function. So in the case of -2, now -2 cannot be less than itself, so this first description is disqualified. Now we have for the compound inequality, now still -2 cannot be less than itself, but it is equal to itself, and in turn -2 is less than 5. So this part, so -2 is equal to itself. So this whole compound inequality is true for the input at -2. And just like 4, it is going to receive the 3x squared treatment. So we have 3 times the square of -2. -2 squared is 4. And 3 times 4 is equal to 12. And we have for the input value of 5. Okay. And here, where 5 appears, now -2 is less than or equal to 5. Now -2 is less than 5, but 5 cannot be less than itself. So this compound inequality falls short. And then for the last inequality statement that mentions 5, now 5 cannot be greater than itself, but it is equal to itself. So the equal part section is true, and so 5 is going to receive the 3x plus 4 treatment. So for f of 5, okay, we're going to have 3 times 5, followed by the addition of 4. 3 times 5 is 15. And we have, in turn, 15 plus 4 is equal to 19. And also, you can go ahead and be looking on page 225, numbers 10 through 26 even. And again, if anybody needs to get in touch with me during my office hours online, I do have my Zoom meeting ID and password. And if anybody has questions, I will stick around. Otherwise, we will pick up next time on Monday.